Yaskawa. This video shows how to command simple motion with the SigmaLogic servo using Yaskawa's AOIs in the SigmaLogic's 5000 programming environment. We'll show how to enable and disable the servo, jog, relative positioning, set the zero position, absolute positioning, stop a move in progress, and handle faults. This is video number 3 in the Quickstart series. The SigmaLogic has been configured and tested within LogicWorks. The Ethernet IP connection has been established in SigmaLogic. All AOIs have been imported, and MCFG has the heartbeat. My PC is running SigmaLogic's 5000 version 20, and the project is online with the CompactLogic's L32E, which communicates over Ethernet IP to the Yaskawa SigmaLogic servo. In the SigmaLogic software environment, Yaskawa claims expertise only in the functionality of our AOIs and in configuration of the Ethernet IP connection to SigmaLogic. This is not training on SigmaLogic's or application programming. All SigmaLogic's programming and networking questions should be directed to Rockwell. To turn the servo on and off, I have added 2 more rungs with contacts in front of MSO and MSF. That's motion servo on and motion servo off. Enter the instance and set the access to Yaskawa servo_1 as defined in MCFG, and turn on the flag for MSO. Servo on and standstill are reflected in the MCFG block. Note that the servo cannot be turned off at the same time, and a fault is output. To disable the servo, release MSO, then toggle MSF on and off. Now that the servo's on, test out motion axis jog with a contact in front of MAJ. The instance and axis are set as with the other AOIs. All of the inputs require either tags or constants. I have tags for direction, speed, XL and decel, and appropriate values. The units for these values correspond to what was set in LogicWorks. For speed, that's millimeters per second. I've set the direction tag to 1 for reverse, and I've entered zeros to disable the optional registration feature. Be sure the servo is enabled, no other AOI are active, and that the speed, XL and decel are not 0, then activate MAJ. And the motor jogs. The MCFG block confirms the speed with the feedback status. Notice that motion stops when the input to MAJ is false. While jogging, it is not possible to turn the servo off. This is because, generally speaking, only one motion AOI may run at a time. Speed, XL, and decel for MAJ can be changed during motion and have immediate effect. To change direction, you do have to reactivate the AOI. Now to implement a relative incremental move with MAM, motion axis move. I've called the instance MAM R1 for a relative move on Yaskawa servo 1. F1 help describes the available move types. Incremental relative move type is number 1. I've created variables for position, speed, XL rate, and decel rate. Registration is again an optional feature and can be zeroed out when not used. Now let's test it out with a distance of 20 millimeters and a speed of 10 millimeters per second. And the motor moves the program distance. Use motion axis home set position to set the 0 point for the absolute move type. This 0 point can also be established through a homing routine using the motion axis home AOI. I have jogged the axis and visually aligned it to the 0 point. Now execute the MAHSP instruction, and MCFG shows the new coordinate position is 0. To make absolute moves on a linear axis, use MAM, but set the move type to 0. I have a separate instance, MAM_A1. The motor will move to the absolute position relative to the 0 point of the coordinate system. I'll enter position 10 and start the AOI. To move again, change the absolute position to another value, such as -10. And back to 0. A typical program will have several AOIs operating on the same axis. But when a move is in progress, executing another move on that same axis is ignored. Re-executing the same move or changing any of the input parameters is also ignored. To cancel a move, use the Motion Axis Stop instruction, MAS. MAS will immediately stop any move in progress, and another move cannot be initiated while MAS is active. If I jog too far and hit the hard stop, a fault is generated. A710 is the hexadecimal alarm code for over torque as displayed on the SigmaLogic front panel. MCFG also shows the code A710. Alarm description is also shown in the axis structure. In this example, the axis structure is named Yaskawa Servo_1. In the watch page, expand the structure and look at element I, and at the top is the sub-element alarm text with the alarm code and description. Motion Axis Fault Reset, MAFR, can be used to clear the alarm on this axis. First, release all active AOIs. Toggle MAS to stop and abort all motion. Toggle MSF to ensure the servo is off. And finally, toggle MAFR to reset all faults. The servo can then be re-enabled, and motion can resume. These are just the basic motion AOIs. The SigmaLogic is capable of advanced motions such as blended multi-speed moves, registration moves, and high-speed indexing. We have an entire video dedicated to homing, and also look for our e-learning video on how to use the LogicWorks sequence table to create a series of moves that can be initiated by the PLC without complex ladder sequencing. Thanks for watching this video, and remember yaskawa.com/SigmaLogic for videos, documents, software, firmware, AOIs, and more.